Hello, in this video we're going to be discussing partial fraction decomposition. So in order to start this topic off, I would like to recall the process of adding rational expressions. So I'm going to walk you through one and then I will ask you to pause the video and practice the second one on your own. If you feel confident in adding rational expressions, then go ahead and pause the video now and practice both of these on your own. In order to add rational expressions, I must have a common denominator. So if I look at the factored form of my first fraction, I have an x minus 1. And factored form of my second expression, I have a 2x plus 1. I can't factor these any farther, so these are the two factors that I'm going to use to find a lowest common denominator. So that lowest common denominator will be the product of those two denominators. So I need to multiply the left by 2x plus 1 on the denominator and also in the numerator. And then in the fraction on the right, I'm going to multiply by an x minus 1 in the numerator and the denominator. Doing so, my first fraction, 2x plus 1 times 1 is just 2x plus 1, and my denominator I will leave in factored form, so 2x plus 1 times x minus 1. From here, I'm going to add on that second expression, 1 times x minus 1 in the numerator, which is just x minus 1, and the denominator is also 2x plus 1 times x minus 1. Now that I have a common denominator, I can add the numerators. So in the numerator of the fraction, I've got 2x plus 1 plus an x minus 1 over my LCD, which is 2x plus 1 times x minus 1. And then simplifying the numerator, 2x plus x is 3x, and positive 1 and negative 1 add to 0, so I just have 3x over my LCD of 2x plus 1 times x minus 1. And this would be my sum of the two original rational expressions. We could multiply out the denominator to simplify completely, but I'm going to go ahead and leave it in this form. So if you haven't already completed your second example, go ahead and pause the video and do that now. So my LCD here is going to be 3x minus 4 times x plus 2. So I multiply by x plus 2 in the first fraction on the top and bottom, and 3x minus 4 in the second fraction on top and bottom. Distributing on the left, I'm going to have 2x plus 4 over that LCD of x plus 2 and 3x minus 4. And distributing on the right, I'll have 15x minus 20 over x plus 2 times 3x minus 4. Now that I have an LCD, I can add the two fractions. So 2x and 15x give me 17x plus, and then 4 and negative 20 give me a negative 16. So 17x minus 16 over 2x, x plus 2 multiplied by 3x minus 4. So again, we took two separate fractions and added them to simplify. Now when we are talking about partial fractions, partial fractions or partial fraction decomposition is the process of doing this in reverse. So we are going to take a single fraction and we are going to decompose it into individual fractions that could be added or subtracted to form that final fraction. So we are going to start by just writing the form that we would use to decompose the following expressions, but we are not going to actually complete the process here on this slide. What we need to do first, step 1, is we need to fully factor the denominator. Once we have factored the denominator, then we can see the two individual denominators that our fractions are going to consist of. So step 2, we are going to write fractions with factors as denominators. So here's what that's going to look like. I've got a denominator in my first fraction of x minus 1, and I've got a denominator in my second fraction of x plus 2. We are going to be adding these to obtain 1x minus 1 times x plus 2. Now we don't know what our numerators are. It's probably not just 1, because adding the x minus 1 and the x plus 2, I need to manipulate this so that I have an LCD, least common denominator. So I don't know what the numerators are, so all I'm going to do is fill in my first fraction with an a and my second fraction with a b. We would then complete this process by solving for a and b, which I will show you a little bit later on in our notes in this video. So for our second example, I want to write the individual factors as the denominators of my two individual fractions. So I'm going to take this denominator and factor it. When I factor it, I get x plus 4 times x minus 1. So that means that one of my fractions will have a denominator of x plus 4 and the other will have a denominator of x minus 1. I don't know what the numerators are, but I know that when I add these two fractions, I should get x. So I'm going to fill this in with just an a and a b for now, because we are not sure what those numerators would be. Later in this video, again, we will complete the process and solve for those variables. Go ahead and take a moment to pause the video and try setting up the form of fraction decomposition for that third example on your own. So here, when I factor, the only thing I can do is take out a GCF of x, and I'm left with x minus 4. So that means my two fractions have a denominator of x and x minus 4, and I'm leaving the numerators as a and b for now. Now what we're going to move on to in the next slide is we are going to see what happens when we have repeated factors. So for example, in this first expression that I give you, I have x minus 1, but it shows up 3 times. So I've actually got 4 factors here. I can divide this expression by x. I can divide this expression in the denominator by an x minus 1. I can divide that denominator by an x minus 1 to the second power, or I could divide it by an x minus 1 to the third power. So we must have all of our factors represented, all of those possible powers of each factor represented as I've done here. So then I fill in each of these with a, b, and then I would have c and d. It is important to note that each of these numerators has a degree 1 less than the factor that we have in its denominator. So this is x to the first, so I have a and then no x's, or x to the 0. This is x to the first, and then b, x to the 0, or no x's. The factor that I'm using in this third fraction is x minus 1, which is x to the first, so c, x to the 0, and same thing for d, x to the first, so this is d, x to the 0. So we have decreased our degree on our factors by 1 for the degree of the numerator. So go ahead and take a moment, pause the video, and set up the form for the following two fractions for fraction decomposition. So I would have 2x, I would have 4x plus 3, I would have 4x plus 3 to the second, 4x plus 3 to the third, and 4x plus 3 to the fourth. I would be adding all of these fractions, and since all of my factors have a degree of 1, I would have no x's in my numerators, just a, b, c, d, and e. And last, I would have negative 3x plus, then I've got 2x minus 5 to the first, 2x minus 5 to the second, and 2x minus 5 to the third. all of these factors have a degree of 1, so we're just looking inside the parentheses here, degree of 1, degree of 1, degree of 1, degree of 1. So all of my numerators are going to have a degree of 0, which means just A, B, C, and D. Moving on to our next slide, we are actually going to complete the partial fraction decomposition of this expression. So I know that my first denominator is going to be an x minus 1, my second denominator is going to be an x plus 2. I am adding, and my numerators have a degree 1 less than the denominator, so that would be just a and b. Now at this point, I need to solve for a and b, so what I'm going to do is multiply by the denominators to clear all my fractions. So on the left, I multiply by x minus 1, x plus 2, and then on the right, I multiply everything by x minus 1, x plus 2. And simplify. So my fraction on the left reduces completely. The x minus 1 reduces in my first fraction on the right, and x plus 2 reduces in the second fraction on the right. So on the left I have 1 equals a times x plus 2 plus b times x minus 1. Distributing, I've got ax plus 2a, and distributing, I've got bx minus 1. I'm going to go ahead and put my x's together, so I've got ax plus bx, and then the x to the zeros, or my 2a and my minus 1 together. And what we are seeing here is that on the left-hand side, I have 0 x's, but I have a positive 1 as a constant. So that means that on the right-hand side, if I have 2 x's, I can factor that x out and be left with a plus b. But if that's supposed to be equal to the 0 x's we have on the left, then I know that a plus b has to equal 0, because there are actually no x's in the expression on the left. On the right, I have a plus 2a minus 1, so this would be my constant term. There are no x's here, which means that that will be equivalent to the constant term on the right, which is a positive 1. So I can write two equations to solve for a and b. The first is that a plus b, that coefficient on x has to be 0, and the second is that 2a minus 1 has to be equal to my constant, which is 1. So I can solve for a by adding 1. A is equal to 2, which means a is equal to 1. Then going back to my second equation, I can substitute a in. I know that a plus b is 0, but I just found a, which is 1, which means that b must be a negative 1. So going back to my partial fraction decomposition then, I found a and b. So a is over x minus 1, b is over an x plus 2. A is 1, b is negative 1. So my partial fraction decomposition is 1 over x minus 1. And then since this one is negative, I can write this as minus 1 over x plus 2. And this would be the partial fraction decomposition of our original expression. For the next two cases, the first thing we need to do is factor our denominators. So I'm going to go ahead and write this in factored form as x minus 12 over x times x minus 4. And now I can write my form for my decomposition. I would have a denominator of x and a denominator of x minus 4 with numerators of a and b. Multiplying both sides of my equation by the LCD, my fractions will all reduce, and I will be left with x minus 12 is equal to a. My x is reduced, so x minus 4 plus b times x. And then we distribute to simplify. From here, I want to match my coefficients, so I need my coefficient on x, which is 1, to match the coefficient of x on the right. So I'm going to group my x's together, and then my constants together. And then I factor out an x on the left. So a plus b is the coefficient on x, which should be 1. So my first equation is a plus b is equal to 1. And my second equation is that negative 4a has to equal negative 12. Solving for a, I find that a is going to be positive 3, which leads me to b is negative 2. I now replace a and b, and I'm done.